Okay, so the lab for last week, which was part lab, part homework, had a lot to do with writing a combination of code using functions and pointers and arrays. It's kind of like the holy trinity of everything there is in C++. It was difficult because it was intended to use all the different pieces of what you've learned. The tricky parts came from trying to understand how to combine everything. It's hard because sometimes you are so caught up in just how to do it, like how to write the syntax, that you can't even really realize how you would write the code, even if you didn't have to worry about the syntax at all. It's almost like you're all kind of like underwater right now. You have to get your head above water to understand how this stuff works. So what I'm going to do is I'm going to write this lab, and then at any point that you guys are having questions about what I'm doing, stop me, and then I will explain it in more detail. And then that way we can all kind of benefit from areas that people had problems with. Okay. All right. So let's start with I'm going to start with a blank project because I'm going to do this from scratch, and that way everyone can kind of see what is needed to do this homework. So the goal was that you would get a program that would ask for what Pokemon and what input you wanted to get, and it would continually ask that from the player so that you can continue to get more information about the various Pokemon that live inside of it. So let's do here. The goal being that you have an interactive experience with the game, and you have a back and forth relationship with the game, and it's asking you for things that you care about, and you're actually providing input for it. So if I just go, there are about 29 things to go over. So let's just start with the beginning. So we're going to create the structures necessary. So actually a lot of people did this in class already. So there are two structures that you needed. One was called a move, and one was called a Pokemon. And the move had these variables inside of it: power, accuracy. So we'll just create power. And I'm creating variables here. It also had a string for name. And for brevity, I'm going to do this. And I don't normally do that. So, okay, so there's name. There's a structure for representing a move. Then we had our Pokemon, which had HP, attack, defense, and then speed, and then special attack, which we call an SP attack, and then special defense, like so. And then it also had a name. It also had two moves to it. So this Pokemon has two move pointers. So the kind of weird part, I think, for some people is using pointers versus not using pointers, and understanding why using one is different than using the other. So where you use pointers in this example, you can actually do this entire lab without using pointers. That wouldn't actually be very useful, but you could do the entire lab without doing pointers. The reason why you can do it is that there's no specific reason to do that unless you were developing a game, or in our case, you're making something that passes moves around from function to function. So for us, we're going to use pointers, but I will show you a little bit about why this is using it that way. So this is an array. This right here is an array of two moves. This is an array of two move pointers. All right, that's just all it is. Compile, make sure there's no errors. So I always build, make sure this thing has no errors on it. Cool. And then the number 5 was to create a global array of Pokemon pointers with two elements called Pokemon list. So I wanted to create a Pokemon. Thank you. Pokemon list with two elements in it. This is just like the move list. This is two Pokemon pointers that lives in a global scope, which means it's outside of the main function, and this means that I can use this in any function that I want. Okay. Fill out two Pokemon in the array. I chose Bulbasaur and Ivysaur inside of your main function. So for this, I'm going to actually save a little bit of time because there's a lot of typing involved. I already did this like 3 times, so I'm going to, what I'm going to do is I'm just going to pull the part for initializing the Pokemon here. So this is how you initialize a single Pokemon. You create a new Pokemon pointer first, so you use the new operator because you have to fill it in. If I left this out, meaning that if I did not do that line, that means that now I'm trying to access memory that doesn't exist. This operator here, the arrow member operator, it says, hey, whatever this thing is pointing to here, go ahead and get the name. And if you don't do this first, you have nothing to point to. So let's just go over this. I'll just copy all these. So I created 6 Pokemon. And specifically, the syntax here is that I am getting the Pokemon at the 0 index. I'm getting the Pokemon who's the first Pokemon in my list. That's this guy right here. And I'm assigning it to be a new pointer. And this guy will have 6 elements inside of it. And if these weren't pointers, if this wasn't a pointer at all, I don't need to do this line, and these would change to be something like that. And that basically is what the syntax looks like if you weren't using pointers. Because we're using pointers, we need to use the arrow membership operator, and also because we're using a pointer, we need to initialize the Pokemon to be new. And again, pointers will help us be more efficient about passing these Pokemon in and out of functions, because every time that you pass an object through a function, it copies all the values of that variable. If you use a pointer instead of a non-pointer, then you don't have to copy every single variable. So moves are kind of the same thing. So here, I want to get the first move inside the first Pokemon. And here, I want to get the second move out of the first Pokemon. And these two moves are both pointers themselves. And I kind of want to show you a different way that you could do this. Like if I created a Pokemon, I'm just going to create a Pokemon pointer called Bulbasaur. I'm going to set him equal to Pokemon list at 0. So this guy right here represents Bulbasaur. I can actually remove all of these like this. And this is exactly the same as what was written before. I have a Pokemon pointer called Bulbasaur, and he's pointing to the first element in the array. And the nice part about this is that this pointer is pointing to the same thing that this pointer is. So they're both pointing to Bulbasaur, which means that I can just initialize his move list like this. It makes it a little bit more clear than doing this, right? And if I were to do this up here, I can also change all of these to Bulbasaur. So it's the same thing, Pokemon list. So these are all the Pokemon I have initialized: Ivysaur, Venusaur, Charmander, Charizard, Charmeleon. This is the entire Pokemon list. Okay. Questions about this so far? All right. Let's make a function called printAllPokemon. Takes no arguments and returns void. Print all Pokemon. No arguments, returns void. Go all the way to the bottom. Let's implement this guy. All this thing was supposed to do was print the names of all the Pokemon. There should be 2, or 6 in this case. So I'm going to create a loop. It's going to loop over all 6 Pokemon. And it's just going to print out name. And it's going to print out Pokemon list at I. This right here represents the pointer to the Pokemon. And it's, again, the same if I did this. Current Pokemon. I'm trying to do this for a little bit of clarity. Current Pokemon, get his name, and go to the next line. Oh, I didn't include string. And I'll include So I can do... So I'm printing out the name by grabbing the current Pokemon and getting his name from here. The current Pokemon is just what I'm currently looping over. Remember, this variable I is what I'm using inside my loop. And then if I run this, I'm going to build. And let me create a... So what I should see is a list of all my Pokemon, like so. That's what that function is doing. So I'm just looping over all the Pokemon that are in my global scope right here. I'm not using any parameters. I'm not returning anything. I'm just printing them out. All right. Next is going to be print Pokemon. So this right here is the first foray into passing a pointer to a function. It takes one argument, which is a pointer to a Pokemon, and it returns void. So I kind of want to take a little bit of time here to talk more about parameters, because I feel like some people are still a little confused on how these work. So one of the things you have to realize about these parameters here inside a function is all this is just a variable declaration. Literally, this variable that lives in the argument list right here is the same as if it was declared down here. It's exactly the same. The only difference is that this thing is being assigned a value based on who calls it, right? So I have this parameter called Pokemon, and all it really is doing is just declaring a variable inside of my function called Pokemon and assigning it equal to whatever's been passed in. Whoever calls it passes in this Pokemon. So this is why I can have a variable here and then I don't know, a variable here. And these are all variables that live within the scope of the function. Okay? And you can kind of break it down so no matter how many parameters are there, I'm going to have a variable that I can use inside this function. That's the name of that argument that's passed in. Okay, so print Pokemon takes a Pokemon pointer, which means I don't have to care about any of the other parts of this file, right? I'm just looking at this function by itself. A Pokemon pointer that's passed in has all the parameters of a normal Pokemon, including HP and attack and defense. So in this case here, it's supposed to print out the name and all their stats to the screen. So what I'm going to do is I'm going to print out their name. And all I have to do to print out the name is just get Pokemon and get his name right here. No matter what Pokemon, whether it's Bulbasaur or Charizard or Ivysaur or whoever, Baleen, this Pokemon, I can get his name, I can get their attack, and I can get all their other stats here. Name, attack, name, HP, attack, defense, speed, special attack, special defense. So this can be HP, speed, attack, defense, special attack. And I can just get HP here, speed here, I can get attack here, defense here. And there's a lot of parameters, but I can actually get all of them from this one pointer that's passed in. So if I wanted to, I have a pointer for Bulbasaur up here. So what I can do is right after I print all the Pokemon, I can say print a single Pokemon, and it takes a pointer, and I happen to have a pointer called Bulbasaur here. And if I run this, it'll print all the Pokemon, and then it'll print the information specifically for Bulbasaur here, with his HP, speed, attack, defense, special defense. Let me move that all to a new line here. Select all these, do a replacement, selection. So now there's Bulbasaur, and there are his stats. And I could just put on a little separator here. All right. Another example of this is that I could print out any Pokemon. So I could print out the Pokemon list at 2. That's another pointer. And at 5, I could print out both of those guys, whatever they happen to be. So there's Venusaur and Charizard. Okay. These two pointers here are exactly the same as the Bulbasaur pointer that's passed in. Another kind of fun thing you can do is inside print all Pokemon, you have the current Pokemon pointer. You could just call print Pokemon here with the current Pokemon as well. I didn't ask you to do this in the lab. It's just this is an example of what you could do to easily print out all the Pokemon stats. You can see here it's printing out each Pokemon and all of their individual stats. Okay. All right. So moving on. Fill out 2 moves. So now I want to create a function called print move, which takes a pointer to a move this time. And returns void. I'm just going to call this argument move. It's the same exact idea as Pokemon, so it's very similar to how we print a Pokemon. In fact, it's so similar, I'm just going to copy this whole thing. And I think there's only 4 things it prints out now. And it has a name, has a power, accuracy, and DB, which is move. So instead of Pokemon here, it's going to be move, power, move, accuracy. Okay. And here I want to print out the move. So I want to print out the move for the first Pokemon. So I want to print the move for Bulbasaur. I want to get his move list at 0. Again, this can also be, this is exactly the same as printing out Pokemon list at 0, move list at 0. I can also get his specific move with a pointer too. So his move here, called takedown, I can create a variable that's a move pointer, takedown move, equal to Pokemon list at 0, and get his move list at 0. And I can pass this in. Okay. All 3 of these are exactly the same. I get the exact same result, and the exact same pointer gets passed into every one of those functions. All 3 of these are the same move. I'm just getting them 3 different ways. So this is an actual pointer to the move that lives on the Pokemon here. Okay. And running this, I'll get 3 moves printed out. All 3 the same. Tackle, tackle, tackle. Alright, so I'm going to delete all that. Okay. Ask the player which Pokemon they'd like to see information about. Store the Pokemon name inside of a string. So the first thing is to print out all the Pokemon, and then ask, what Pokemon do you want to see? I even gave you the code that you can type in. Okay. So I'm going to build. I'm just going to make sure that it works. Oh, weird.
That looks nice.
That's Visual,
Good to get.
it's Visual Studio. Bulbasaur. Cool. I'm able to type in a name, which is good. Doesn't do anything with it. So I want to implement a function called getPokemon. The idea here that I really wanted to get across is now that you have these functions and all these pointers, is that you ask the player what Pokemon they want, and then you will give the player back a pointer to the Pokemon that they asked for. And that's what this function you're about to write does. So there's a function called getPokemon, which takes a string as an argument and returns a pointer to a Pokemon as a result. So a pointer to a Pokemon is the return type, getPokemon is the name, and it takes a string as the argument. Okay? So the goal of this function is to go through every single one of your Pokemon, find the one that matches the same name, and then return a pointer to that back to the person that calls it. So you need to write a loop here that goes over every single Pokemon. And then if your Pokemon list at I get his name is equal to the name, all you have to do is return Pokemon list at I. If you get all the way through the loop and none of the names match, I asked you to return null. This is a special representation for saying this pointer points to nothing, which is commonly used to indicate that there's no result, there's nothing that matches. For instance, in Overwatch, if I was to say, use one of McCree's ultimates, his ultimate is you press a button and everyone in your field of view starts getting a little skull icon closed in on their head. And if that icon goes all the way to the smallest point and you click, you'll get an instant kill on that person. However, if you're facing like a wall, you have no heroes to target, which means if I were to ask you, get me the person closest to the center of your reticle, you would return null in that case because you're staring at a wall. So null is a very common thing to use when you have no result. And in this case here, I would have no result if you typed in some kind of gibberish name. Another way you can do this is you can create a pointer to a Pokemon internally. So you can say like current Pokemon. And this is also commonly used because it's actually more efficient to save off a pointer than it is to access an element in the array constantly. There's a cost associated with that. So you can do this and a return current Pokemon like this. And that's also fine. Okay. Alright, so lab was call get Pokemon, storing the result into a pointer variable. And what I'm going to do is I'm going to take this Pokemon name. I'm going to get a Pokemon pointer, requested Pokemon. I'm going to call that function passing in the Pokemon name that I just typed in. This right here corresponds to the name that you typed in, and this pointer will be equal to the Pokemon that it found, if there was one. If the requested Pokemon is not equal to null, which means if you actually found one, if this is true, that means that you found a Pokemon, I'm going to print a single Pokemon. I already wrote the function to print it. And I'm going to say, found your Pokemon. And I'm writing this because I want to test my, my logic here. So I'm going to type in Venusaur, which will find me the Pokemon for Venusaur and print him out. Okay. If you don't find a Pokemon, I want to type in something that couldn't find the Pokemon named, and then you could put in the Pokemon name here that they typed in earlier. Okay. So now if I type in gibberish, you'll see that it says couldn't find that Pokemon named this. So let me step into here while I'm here and go over how this function works. So I'm going to type in Charizard. And here's where my instruction pointer is, the little yellow arrow. And my Pokemon name is currently Charizard. Okay. I'm going to step into here. I jump all the way down into this function. The name that's passed into this function is Charizard, which means, again, this argument here is the same as if I declared this here with equal. Okay. That is how that function is working. It's basically saying, hey, there's a variable called name, and it's called equal to Charizard. Okay. That's all this argument has. This argument name is currently Charizard. So it's going to loop over all 6 Pokemon. And I want to show you guys this Pokemon list here. Can you guys see the 6 Pokemon that live in here? Bulbasaur, Ivysaur, Venusaur. These values right here are what's stored inside the pointer. So this is actually what the pointer is pointing to. Okay. And just for I'm gonna show you guys the memory at that location because it's kind of interesting. Can you guys see right here? It might be a little hard to see. It says Bulbasaur there because that's what lives at this memory location. If I grab this, can you guys see that says Ivysaur here? Okay. These memory addresses here is actually pointing to the memory of where that Pokemon lives. So each one of these represents a chunk of data here. You can actually see Ivysaur, and I don't know if you can read, it has Razor Leaf right here and Takedown right here, Because this whole block right here, this section that I've highlighted, is the memory representing a single Pokemon. Okay? And then right next to it is Venusaur here. Petal Dance and Worry Seed. This is where the data lives inside the game as it's running. Okay? That's what these pointers are doing. All right. Okay. So, just going to close that one. All right, so I'm stepping through. I'm grabbing the current Pokemon. The current Pokemon is Bulbasaur right now. Current Pokemon's name is Bulbasaur. So did that match? Nope. I'm going to keep going through this loop until I get something that matches. So I'm currently on Charizard. Charizard does not. Does that equal the name that's passed in? And it does, which means now I get to return the current Pokemon. So it exits the loop, and now I have Charizard stored in this pointer. Okay. This pointer here, the memory address for this pointer is exactly the same as the memory address that's stored in the array. So again, look, this is the name of the Pokemon in the memory, and you can see that this location here includes his name. All right. Notice that, I don't know if you guys can see, there's no, his moves aren't here. Like with the other Pokemon, if I actually grab, like if I grab this memory location for Bulbasaur and I put him up here. So this is actually a good example. C++ decided to rearrange where their moves live. Like look right here, Ivysaur, you can see he has Takedown and Razor Leaf right there. And Venusaur has Petal Dance and Worry Seed. But this guy right here, Charizard, plug him up here, you can see, you can't see his move list right here. Because his move list for Charizard lives in a completely different place. It actually looks like it lives above Charizard right here. If I scroll all the way up here to the address here is going to be 825 DC0. So I'm going to go up to 825 DC0 and see if I can find his move. Aha, I found it. Flamethrower and Fire Spin. So this is how you have to keep in mind that when you're requesting for memory for pointers, that memory can go anywhere. It can come from anywhere inside your program, and it gets pulled from wherever there's room. All right. Okay, I have my requested Pokemon. I'm going to pass my requested Pokemon down here. This happens to be Charizard, and the Pokemon name and his HP and his speed and his attack all get printed out. And so I get Charizard here. All right. So next.
I have a question.
Yeah.
For that part, what are we supposed to do, like a do while loop?
Yeah, I'm about to do that too.
Yeah.
Yep. So you mean like asking for a validate player input, right? Yeah. So this thing, what I like to do though first is I like to work in increments, especially for something that is I'm not familiar with. So I didn't even care about the loop to start. I just literally was like, can I get this thing to work at all? And now that I have this thing working, all I have to do is do a do while around this whole thing that I already wrote and I know works. Like this. And then I can break here. So now my loop will function that if I type in gibberish, it'll keep asking me for Pokemon. Right? Until I type in a valid Pokemon, and then it'll print out the one that I care about. Okay. All right. So that was number 20. Number 20 had a piece, C through F was actually really important to get this thing to work. This variable here, that's the Pokemon that I requested, lives inside of these curly braces here in the loop. For instance, there is no variable called requested Pokemon outside this loop here. However, I need requested Pokemon outside that loop because I need to actually get the moves for that Pokemon. So what I was saying in in E, I need to move this variable, desired Pokemon, to be outside of do while loop and initialize it to null. Which means I need to move this guy. So this guy needs to be moved out here. He needs to be initialized to null so that he's outside of loop, and then I'm going to use him down here. Okay. Because he's outside of loop, now I can use this variable anywhere in the rest of my main function. If he was declared only inside the loop here, like so, I can only use him inside this loop, which means he doesn't exist outside of this do while loop. Which means now I need to move him to be outside. Okay? And the reason is that right down here, we're going to write the next piece of our Pokedex. I'm going to write a function called printAllMoves, which takes a pointer to a Pokemon and returns void. So we're going to do void printAllMoves. It takes a pointer to a Pokemon and returns a void. And it's going to loop 2 times because there are 2 moves for every Pokemon. And for each of those guys, I'm going to do a cout and I'm going to get his move list at I, and I'm going to get that name. Okay. This right here, again, is a pointer that I can save off. I can actually get a pointer to a move, current move, like I said, equal to this. Set that equal to that right there. And then I can use it down here. So printAllMoves. The reason why I need printAllMoves is, again, I'm going to go back to my main function right here. I'm going to call printAllMoves on my requested Pokemon. Remember, this requested Pokemon variable I had to declare outside of the loop so I could use it right here. If this variable was declared inside this loop, I'm going to get a compiler error because this thing doesn't know where that variable is. That variable lives and dies between these curly braces here. So I need to move him outside. And even though he's outside, he's getting assigned inside this loop. So I can be guaranteed that this right here is going to be good. So I'm going to run this again, just to test what I wrote. I'm going to print out Venusaur. He has 2 moves down here, Petal Dance and Worry Seed. Okay. Finally, implement a function called getMove, which takes a pointer to a Pokemon and a string for the move name, and returns a pointer to a move. So it takes a pointer to a Pokemon and a string, and returns a move. So it returns a move pointer. It's called getMove. Takes a pointer to a Pokemon and a move name. And this function right here is the biggest one. And it's actually not, it's just a variation on the getPokemon function. So it's asking me to get the move that matches this name out of this Pokemon. So I know that I can loop twice because there are 2 moves per Pokemon. And I can say, I can do the same thing that I was doing up here. I can get a pointer to the current move. And if the current move name is equal to this name here, I can return current move. Otherwise, return null. And that's all there is to that function. It's actually very similar to the getPokemon function. If you see here, this logic here for getting the pointer and then comparing the name is like almost identical to this thing here where I get the pointer and I compare the name. The only difference is that I'm getting the move list here from this Pokemon that's passed in. And again, this argument list, don't get caught up on it, it's pretty much just this. Okay, you have a pointer to a Pokemon and you have a string. You want to get the move list out of that Pokemon. I like to think of pointers when doing game development almost like, imagine in your head, like literally you have a Pokemon in your hand, like a miniature version of this Pokemon, like a Bulbasaur or Charizard, and you're passing that around, and you're using that Pokemon as if he was like a physical thing, and from him, this pointer to a Pokemon, he has attributes that describe what that Pokemon is, like how many moves he has, and what his name is, and what each move is. And now that you've written this function, you can ask the player what move they'd like to see information about. It's very similar to the asking which Pokemon they want to see. So I'm going to say, I gave you an example. What moves do you want to see? Calling getLine. And then call getMove, passing in the requested Pokemon that you got from earlier. And this desired move, this whole thing can also be wrapped in a loop, just like the other one was wrapped in a loop. Okay? And if the desired move not equal null, you can print the move that you got. Okay? And then you can break. Otherwise, couldn't find the move named. And the move name here is going to be move input. And then that's it. So now if I run this, and do Venusaur, or I'll just do this to start. That works. Venusaur, type in gibberish, couldn't find the move. Pedal dance, one word, doesn't work. 2 words, and it found the move there. Okay? And then, so that was number 26 and 27. So for homework, all right, so before I go on to homework, this is questions on this.
Still kind of don't get the whole declaring the, what was it, the null thing.
Oh, this thing here for,
Yeah.
it's like get Pokemon, this thing here?
Where was I? The Pokemon, desire, or requested Pokemon you had up there.
Oh, I see. So in here, this whole thing?
Yeah, and then you had it outside the loop.
Okay. Yeah, let me, I can break this down a little bit more too. So if I just do this.
Because whenever I would try to run it, when it was declared to null, it would crash.
Right. So if you do this, if I just simplify this, and I do requested Pokemon name, if I just literally just do this, like forget any of the other program exists. Like I've literally like if I just go ahead and just grab all of this, just delete it. So this is my int main now, right?
Okay.
If I just do this, that will crash. And the reason is that, again, whenever you're using pointers, this pointer variable right here, can you see that, Michael, what this thing is pointing to? What is that memory address?
Yeah, it's all there.
So if I go to that location in memory, what's here?
Nothing.
Okay, so if you do something like this, you're asking it, hey, at this location right here, go ahead and get me the name that's right here. And as soon as you get to this one right here, and it tries to resolve this block of, this block here into a Pokemon, it fails because there's no Pokemon that lives here. You can imagine this like his Pokeball, right? Yeah. Like this, there's nothing here for him, which is why you need to do at least something that does this, right? The difference is that instead of doing that, we are asking for we're setting this pointer, right? We started to null. This is what I just did up here. This guy right here, I'm calling a function, right?
Yeah.
Like let's get the function out of the equation here for a minute too. Maybe that'll make it a little bit simpler too. I'm just going to take this function that I wrote down here, this whole thing, and I'm going to write it right here. I'm basically not going to write a function at all. I'm just going to do this. I'm going to loop over every Pokemon here. And an if Pokemon list okay. So if I do this, that's basically what our function is doing.
Okay.
So right here, I'm going through the loop 6 times, right? One for each Pokemon. And then as soon as I find one that matches the name, so this is the name of all 6 of Pokemon, one for each Pokemon. If it matches here, that's what this if statement is doing.
Yeah.
I'm assigning what lives here into the pointer here. So watch what happens when I actually run this. I'm going to do this. I'll show you what happens to the memory here. I'm going to type Charizard. So again, my requested Pokemon is still 0000, right?
Yeah.
It's still pointing to nothing right now. And then I'm going through my Pokemon list, and I typed, what did I type? I typed Charizard, so I'm going to go through this until I get to Charizard. Okay. So I'm going to grab, I is currently 5, so I'm grabbing this guy right here. I'm grabbing Charizard. I'm seeing if Charizard, I'm seeing if this name right here, Charizard, matches the name that I typed in here, which happens to be also be Charizard. And if it is, it goes into here. So requested Pokemon, let me drag this guy down here. So he's still 000 right now, right? So what happens when I assign this guy equal to this at 5? This value here will change. It'll change to the same thing that Pokemon list at 5 is pointing to. So if I do this, so Pokemon list at 5 is currently pointing to, I'll do this. That's what's stored in that pointer. Remember, pointers, all they store is memory addresses. This is what's currently, this is where Charizard lives right now, right? You can see Charizard up here if you can read, but this is basically the Pokeball that Charizard lives in. So if I step right here, see how that thing changed to be the same thing as this? That 806cc0 is the same. So now this variable here points to the same thing that this variable was pointing to. They both have this memory address inside, which means when I get out of this loop, I'm seeing if this variable requested Pokemon is not equal to null. Null is 0. Does it make more sense if it's like this? If requested Pokemon is equal to null, and then else, you could do this. You could do it this way. Let me just rewrite this loop a little bit. It's basically the same thing. So if the requested Pokemon is null, say that you couldn't find it, right? So is this true or not? Like this value null is just 0. Literally this is a number that means 0.
Yeah.
Okay? Will it go into here? Into this if statement here?
No.
Because it's not null, right? It's actually this memory address, which means it gets to go down to the bottom here and print all the Pokemon at that address. So when I run this again, and I'm going to do Charizard again. So now I have Charizard. Notice he's at a different memory location. Again, like this memory address will change every time you run it, but that's basically where Charizard is. And I'm calling this function, and I'm just passing in essentially this memory address. That's all I'm doing. I'm passing in that. That's all this function is doing. It's passing in that. I go into here. Again, this is just passing in. This is basically doing this. Pokemon equals that. That's all that is doing. That's basically you have a variable called Pokemon that lives inside the function, and it's equal to this right now. Okay? And watch what happens to that variable when I step. So I'm going to step one time here. I don't know if you can read this. This is currently the memory address that got passed into here. That's what it is. And that happens to be the thing that was called up here. See 496cc0? And down here, this is also 496cc0. So all it did was copy that memory address into here. And then you can use it in every single one of these lines here. So that's all it's actually doing. This code up here, all it's doing is trying to find a Pokemon based on that name, right? So that's all this thing is doing. If I type requested Pokemon equal to get Pokemon. This is exactly the same as what that loop was just doing. This function is just a loop that loops over every Pokemon and compares the name. So watch. If I do Charizard again here. So Pokemon name is Charizard. I'm going to step into here. Oops. The name here is Charizard currently. And it's going to loop over 6 different Pokemon, trying to get compare each of them. And it's going to go through this loop 6 times until it gets to Charizard, or it returns until I didn't match anything. So here, it found one. So it's going to return whatever this thing is pointing to. And this thing happens to be pointing to this memory address here. That's what's here. It's going to return this. Because that's what this is. That's also what happens to be this. Okay. It's going to return this back to whoever was calling it. And then this is going to get replaced with that answer here. And then it's going to be stored inside this pointer variable. So now, this pointer requested Pokemon, which has this memory address, 64cc0, is used down here. It means it's not going to go into this if statement. It's going to go down here and then print the Pokemon. And again, this thing gets replaced with that same exact pointer. It's that same memory address gets passed around everywhere. This thing gets assigned like this. And if I go to that location in memory, you'll find that it says Charizard right here. That's where he lives.
So after you've done after you're done with that loop, will that value stay at that?
Right. So you mean this loop up here? When I print out all the Pokemon?
And you get it to stay.
Yeah, will
for
it stay
the
there?
moves.
Or will it go back to null because the loop is done?
Ah, I see. So it doesn't go back to null. It stays as long as that variable is alive, which means that this variable is alive outside of this loop. This variable right here, which is the pointer that was returned, this thing lives outside of these loops, which means this variable right here is safe all the way until you get down to here. This variable right here lives within these curly braces, right? Yeah. So the variable lives within the curly brace right at the very beginning, this one here, and it lives until it hits the last curly brace down here. Okay. And in between those, you can get it whenever you want to. You can assign to it, you can use it whenever you want to. And even though you only assigned it inside the curly braces here, even though the assignment lives in there, the variable lives outside of there, which means that variable lives. And so does the value that's pointed to it.
So if you changed it in that do while loop, it's going to change to the one outside the do while loop.
That's right. This right here is changing this variable.
Okay.
I only have one variable, yeah, and it's changing this one.
Okay.
And that's the one I'm using.
And did it matter that it was on top of the do while loop or below it?
It does, because if I try to put it below it, like here, now I can't use it here because the first thing it's going to do is going to look above this line right here and try to find a variable called this above it. It's going to scroll up all the way until it finds a variable called this, and it can't.
Okay.
So in order to use it, you have to declare the variable first, and then you can use it down here.
Gotcha.
All right. Other questions? So the homework was to continue the loop after printing out the move, asking for more Pokemon until they type quit. So it's easiest to do this. I'm going to just minimize all the little pieces. So what I want to do is I want to repeat this entire thing, all of these, both of these loops, like so. And then if what they type in for the Pokemon name so I wanted you to type in quit, and then that'll cause the program to exit. And this thing will now loop forever. And there's a few ways you can do this. I think the easiest way is that you want to keep track of whether or not you should still be asking for Pokemon. And so what I like to do is I like to have a bool variable that says keep playing. I'm going to assume that they want to keep playing. So I'm going to use that as this condition here. As long as you want to keep playing, go ahead and keep looping. So this is the very last while. I have 3 while loops, one inside of each other. Let me do this to simplify this a little bit. So I have this variable keep playing, which is used here. And I want to say when you ask for a Pokemon, if the Pokemon name is equal to quit, I'm going to say keep playing equal to false. And I'm going to break out of this loop right here. Breaking out of this loop here breaks out a loop here and takes me to this line right here. Let me turn on line numbers here. Make it a little bit easier. Takes me to line number 202. And in here, if I shouldn't keep playing, I'm actually just going to do this. I'm just going to break out a loop right here. And actually, I don't need this after all. I'm just going to keep this to be true. And the reason is that this variable here will tell me if I want to keep playing or not, and then break out early when I'm done. All right, so now whenever I'm asking for a Pokemon, if I type in quit, I'm going to do one loop through. I type in Charizard. And I type in Flamethrower. I want to quit. Thanks for using Pokedex. It'll exit everything. And the reason why this works is that when after I've typed in a Pokemon name, if this is equal to quit, I set this variable to false. That's saying I don't want to keep playing anymore. I break out of this loop. And as soon as I break out of the loop, the first thing I do is throw that condition into an if statement. And if that thing is false, which means I don't want to keep playing, I break out again. This is a double break. I'm breaking out twice out of both of my loops that I have. Okay? All right. Finally, there's a function called getDamage, which takes a pointer to a Pokemon and a pointer to a move and returns an integer for how much damage that move did. This is take this function here returns an integer and 2 pointers, a Pokemon and a move, and it prints out how much damage that move does. And what I want this thing to do is I want it to print out based on this formula that I have. I want to return. So I'm going to create a variable called damage. I'm going to set it equal to 0 by default. And damage is going to be equal to, looks like, just going to literally be the number 2. I'm working from the right to the left here. Base is the power of the move, so I'm going to get the move and get the power. Times, looks like it's going to be attack of the Pokemon. It's going to be Pokemon's attack, get his attack. Divide this by 50, I think I said. Defense will be 50 here. And then multiply it by 2 times the level, which will always be 1, plus 10, divided by 250. Okay? So this is getting the power from the move, multiplying it by the Pokemon attack divided by 50, and then taking this equation here and multiplying that as well. Okay? So now that I have a getDamage function, as part of printing a move, if I go all the way to the top here, so I'm printing out a move here, I can also say the damage for this move is now, I can just call getDamage, pass in the requested Pokemon, and pass in the desired move, both of which are pointers I have. And now not only will the move print out the information about that move, but it also will print out the damage. So if I type in Flamethrower here, the damage for this move is 6. Okay, based on my attack and a defense of 50. If I want to see Bulbasaur and see Tackle, the damage for this move is 2. And this thing wasn't really that much different from any of the other functions that you wrote. The only difference was that it took 2 pointers, so it took a Pokemon and a move. And what's nice is that you don't actually have to pass in a Pokemon that you asked for. Like, let's say I want to know how much damage a Flamethrower would do if Bulbasaur did it, right? I could actually just do that as the first thing. Bulbasaur's theoretical damage with Flamethrower is, get damage for Bulbasaur, which I have a pointer. And I need to get the flamethrower move, which happens to be Pokemon list at 5, move list at 0. So I can just pass that in over here. And now, when I run this, I get Bulbasaur's theoretical damage using flamethrower. Is 2. Because it doesn't care whether the move belongs to the Pokemon or not. It just cares about whether I have a move at all. I'm literally just passing in a pointer to flamethrower. And to make this, I can do the same thing. I can get a move, flamethrower move. I can assign it equal to that specific move at that index. And I can pass that in here. Like so. All right. Okay, so that's the entirety of the lab and the homework. There are a lot of pieces to it, a lot of function writing. You will be writing more functions and using more pointers, so we're going to be doing more of that stuff today. Let me collect all the homework first, so see how far everyone got. And then I want to take a... we're going to basically be moving on to doing a lab with SFML. So I'm going to go over the lab first, and then I'll give you guys the rest of the class to kind of work on it. So I want to go over the concepts behind how SFML works. So I brought in today kind of what I did last class, an engine that you guys can use. So this is a C++ solution that's already built for you. This C++ solution is intended to be used so that you just open up the solution, and then when you run it, you should get a green circle. So I'm going to put this up on Zool. Make sure you copy this to your computer. If you run this and start editing it, you'll be affecting everyone who uses it. So create a copy of this lab first.
You should just go ahead and just take points off.
Yeah, I should just do that. Just assume.
Is there a way you can save that and put it in the
Oh, the source?
Yeah.
Okay, yeah,
Just so
that's
we
a...
can see it.
That is a good idea. I'm going to... Let me save this source file, and I'll put this up on Zool so that people can look at it, and then let me know. So yeah, I just copied that to Zool so you guys can use that Pokedex.cpp. Yeah.
Did you still want my homework even though it's like broken?
Yes. I want to see effort. I don't really... The specifics of whether it works or not is actually not that important to me. Yeah. Yeah, sure. Yeah. How about during break? Okay. So copy it and open up the engine.sln solution file. It should open up in Visual Studio. And just hit F5 to make sure it runs and you see a green circle. Because we're going to be doing this as part of our lab. Everyone should see this, which is 1024 by 512.
Oh, this is like what we're learning in our math class right
Oh, really?
now. Yeah.
What are you guys learning in math class right now? What's
Geometry for geometry.
What is what do you mean? What like specifically? This is just a green circle.
Yeah, like we have to build shapes and stuff. Like they'll give us a whole bunch of coding, and then we have to like change in the vertices and everything,
Uh-huh.
like the color and the
Yeah.
size.
You're not actually working with vertices here. You're just going to be working with rectangles. Because again, we're making Pong. So the goal is that you'll understand how to use the rectangles and understand coordinate systems in games.
Yeah, that what we're learning is you keep using triangles, squares, and just like making them flip over, change position.
Are you doing that with 3D? Like are they 3D? So you guys are using OpenGL for that stuff? Okay. Yeah, that's great. I'm really happy you guys are learning that. That's super helpful for understanding how games work. what I'm going to be pushing us to do is doing practical application of learning how to use those things into more of game development. To that effect, everyone should see a green circle. Everyone got this project and is running it. Everyone got a copy of it. I don't see green circles everywhere.
So to get edited around, you always have to get it sort of from an outside code, like you can never build it just straight up from C++.
You mean write it all by yourself? You could do it. It would take you a while.
Is it like, yeah,
SFML is written by many people,
right.
and it's not just one guy that does it. So, what is
Which one am I looking for?
did you open up? It should be something called engine.sln.
Oh, okay.
No, you have to open up the entire
Why
solution.
the whole thing? How do you do that from inside here?
You just double click. You can do a file open solution. First one. Yeah. Green circles everywhere. Okay. As part of the necessity to learning how to make Pong, we have to start stepping away from focusing on syntax for things like loop. I'm going to start trusting that you guys are able to discuss. If you need to write a loop, that you will be able to write a loop if you have to, or if you need to write a function, that you at least understand the basics of how to write a function. And you might have to look up the specifics, but we're going to have to spend less time doing that stuff, and we're going to have to start training your brains into thinking about how to make games, like how to think less about the programming language and think more about the game. And we are still using C++ a ton. It's not that you have to stop learning C++. It's more like now you have to both learn C++ and game development at the same time. So you have to understand how to apply everything that you've been doing into this. I want to have a little bit of lecture along with this lab. So I'm going to go over the lab here first. I'm going to show you what it is. So this lab is going to be a series of practice. This is lab and homework. A series of screenshots that you need to basically mimic. So you have screenshots, and I need you to make your game look like the screenshots, okay? The first thing is just draw a green circle. Yay, everyone got this working. You guys did lab number 1. Congratulations. You guys are expert game developers already. The second one is I want you to draw it with Overwatch Orange. So Overwatch Orange is kind of this, I give you RGB values for this. And I'm going to go over a little bit more about how to get to the information that lets you do this. The third one is I want you to draw a texture to that circle. So I want you to apply this brick texture to that circle that you drew. This one is using rectangles and colors. I want you to draw a fake Pong board. None of this stuff moves. It's just 2 paddles, red and a blue, and then a dividing line with a square ball. Okay? This is drawing the paddles at specific locations on the screen, so understanding the coordinate system of how the game works. Next, I want you to draw the word hi using rectangles. Okay? Kind of tricky. You have to kind of understand really width and position and height. And I expect it to be clean like this, no overlap or anything like this. It has to be very clean. Next, I want you to draw 100 randomized circles with random colors, random sizes, and random positions. This is going to be using loops and arrays to draw this. I give you a little bit of a hint. You should declare an array of 100 shapes and initialize them all with random values. I give you a little bit of a snippet to try to get you started, just so you're not like completely lost. But I have to have you fill in color, position, radius. Next, I want you to draw a full screen sprite with this huge texture. This texture here lives inside of the engine folder that you obviously copied, right? Everyone copied. So inside engine content, there is a huge, this is 1 megabyte image. Please don't open it up in fireworks. So it's a giant image. It has a ton of Pokemon in it. And this is the first step into learning how sprite sheets work. So a sprite sheet is basically a huge image that has a bunch of smaller images inside of it. The first thing for this lab is, oops, I accidentally just closed it. The first thing for this lab, this is number 7. So draw this sprite. And then number 8 is, I just want you to draw Charizard from this sprite. Literally, I want you to take Charizard, who is right here, from this image. I want you to pull him out without using, this is not using Photoshop, this is just in code. You're taking Charizard, you're taking a section of this image, and you're just drawing that. Because this is how you do animation. In animation, you take sections of a big image and you cycle through each one of these. This one, I just want you to take Charizard, pull him out, and draw him on screen. Every Pokemon is 97 pixels apart from one another, and each Pokemon is 97 by 97 pixels wide and tall. After you draw Charizard, I want you to draw, I think this is Wailing. Wailord? Oh, isn't there like a Wailing or something like that? Isn't there like a Whaler version, a smaller version?
Whalmer.
Yeah, Whalmer.
Wilmer. I think he's like, so he's like 10 columns over and 10 rows down. Yeah, these guys. This guy right here. And then there's a shark guy too. I don't know the shark guy. Sharknado. Yeah. So I want you to draw him specifically. Just him. So pull him out of it. So I want you to draw, then I want you to take a different sprite sheet. So it's the same idea, it's just a different image. So I happen to have one included here. Oops, don't use that one. That was no good. So this one here, so one of these sprites here has him attacking downwards. Where is it? Yeah, one of these. I just want you to draw this guy right here. Okay? So he happens to be, looks like it's going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 5 rows down, 6 columns over. Okay, draw that specific sprite. And then draw a background, which is a very large sprite, which I have included also. It's a Lost Woods texture. This one right here. Draw that, and then draw a link on top of it. So understanding how the order in which you draw things is important. And then finally, this is probably going to be for homework, you have an explosion image. These are how explosions are still made. By the way, this is how we make sprite sheets and animations in Overwatch. Like, you want to do fire, you want to do explosions, you make a flipbook like this. Flipbook texture is basically a series of images that have a progression in them to get you an animated look. So this right here is an explosion with, I think this has 9 by 9. And what I want you to do is draw each piece of these for a little bit of time, and then move that square that you're drawing over and over again. So I want to get into a lecture about how textures and UVs work. Has anyone heard of the term UVs yet? A little bit? You guys have heard?
Oh my God, yeah.
Okay. The goal being that, let me just show you what this looks like here, because I do have this thing working. And then I'm going to get into the lecture.
I hate you.
Excuse me. I don't remember what I was using as my, I think I'm using, so let's just speed this up a little bit because I think it looks better when it's faster.
You're programming, right?
Can you guys see that explosion? That's just this, one frame at a time, right? Every single one of those is baked out. You know, you'll take an After Effects like thing that you've done, you'll bake it out to a flipbook, and that way you'll load it into a game as a flipbook, and then it can animate that sprite. Right? Even though this is 2D, this is also how you do things in like Unreal, for instance. You want to do an explosion in Unreal, like with a particle, a lot of times you do something like this. Or fire is a good example. Lightning. Anything that you want to look like it's animating over time, it's done like this. Our ultimate meter in Overwatch on the HUD that has a little lightning on it is done with flipbook like this. Someone hand animated like lightning. Ben Zhang, who's a master of that stuff.
I mean, can you say that's the same thing for like even a walk cycle, like a AI walk cycle?
Yep. 3D games are a little bit different. 3D games don't use sprite sheets for walk cycles. Like if you're doing like an Unreal animated 3D dude, typically that stuff is keyframes. So you'll put keyframes down for each pose of like where it is, and then it'll
Animation.
yeah. This is more like 2D games, but at the same time, this technique is still used for 3D games. But again, like more for particles and for anything that you want, like UI that you want to have animate, like between sprites. This is still used. This is still really useful for games. If you ever want a walk cycle for a game, in fact, you can see here in this example for Link here, up top here, this is actually a walk cycle. Let me show you what that means. You guys want to see a walk cycle for Zelda or for Link, or the Zelda game? What was that called? Zelda.png? How many cycles? 1, 2, 3, 4, 5, 6, 7, 8.
Then you just give us that code, right?
Yeah, you just.
Yeah, go ahead and just use that. If you guys can make it work with this, then props to you. Might be a bit too much.
Sounds like an ultra spin.
It's too fast. Too fast.
That's like his ultra.
Oops.
Or his face.
Also the wrong row.
Oh, now he's wrong.
Looks like he's moving too slow. So I'm going to increase the time between animations.
Yeah, this one's. What's my Game Boy Advance?
This technique will work for any sprite sheet that is aligned correctly. So let me go over the specifics of how to do these labs in detail, and a little bit more about games and positions. So I have this lab, which is our green circle. And I have some sprite sheets. So I'm going to go over coordinates. Have you guys learned coordinate systems, like upper left corner and bottom corner and stuff? Okay.
Not
Yep.
too much in that. But
Should I go over that?
Oh, well,
Just make it white on the background.
advanced classes.
yeah, we.
Okay. What is this? I don't know what that is. This is a very standard window for SFML. This thing is currently 1024 pixels wide by 512 pixels tall. The coordinate system here, starting at 0, 0, goes all the way to 1024, 0, and this is over here is 1024, 512, and this is going to be 0. So this is the x and the y coordinates for each of the corners of the window. X, y, x, y. You're going to become very familiar with the x and y coordinates because you need to know on this grid where to draw things. For instance, when you want to create the paddles for Pong, you need to draw them over here and on the right side here. So SFML gives you the ability to specify positions for where to draw things. And inside the lab, I've put 2 links to the various ways you can draw things in SFML. The first thing is going to be a link to drawing shapes. Talks about all the various ways you can draw rectangles. So here I want you to use this as a resource. So I want you to look at this web page, and I want you to read how to draw each of the various pieces. So for instance here, the first example is how to draw a circle and set its color to green. And guess what? You need to know this in order to set the color to be Overwatch orange for lab number 2. If you want to learn how to draw a rectangle, you scroll down, and this is how you specify a rectangle. So the way that you draw things in SFML is you create a shape of any kind, whether it's a rectangle or a circle, or you can create triangles too, which are just circles with fewer sides. Once you create a shape, you create a variable for a shape. This is just like any other variable. You have to draw that shape somewhere. So right here in the code, you'll see a line, and this line here is responsible for drawing that shape that you created. Whatever shape you want to draw, you're going to create this line for every shape. For instance, if I wanted to draw 2 circles, I would create 2 circles, and I would draw both of them down here. I'd have 2 draw calls, one for each circle. So the way that SFML works is, let me just break down. I think I did this last quarter as well, but I'll do this again for review. Notice up top here, I have a variable called shape. It is currently 100 pixels for its radius, and filling it to the color of green. And if you look at that web page that I give you a link for, there's several ways to specify a color. There's some hard-coded colors like green, red, blue. Some colors that the guys that wrote SFML kind of created ahead to make it a little bit easier for you. But you can explicitly say what color you want, which is what you're going to have to do for Overwatch Orange. Then there's one big while loop here and a return 0. Without this while loop, it looks very much like any other main function, right? It has some code, and then it calls return 0 at the end. This while loop here has behavior to handle events like, hey, I click the X button. You're not really going to be changing this code at all. You can almost kind of think of it like just don't touch that code for now anyway. We'll get into more of this stuff later. And then down here is where the actual magic of drawing things to the screen occurs. So the first thing that we do is we clear the window to be white. And then the next thing that we do is we draw any shapes that we want, and then we say display, which will take those things that we've drawn and present them to the monitor. All right? So what I want you to do is I want you to look at the first example for how to draw shapes. If you want to see how to assign a texture, this also has an example for how you assign a texture.
That's cool how we can do the texture part. We haven't done that.
So the second link, the sprites, shows you how to load a texture. You can follow this code for how to load a texture. And once you have loaded a texture, so the examples in this is how you load a texture right here. The first thing you need to do is create a variable for a texture and then load it. Once you have a texture that you've loaded, then you go back to the other web page. And this guy right here shows you how to set that texture up on a circle. You only need this line right here for setting a texture onto a circle. I'm going to go over this in more detail next. So what I want you to do is try to draw a texture, or load a texture, and then draw it. So in the lab, I give you what path to the texture you need to draw, you need to load. So for this texture, for instance, I say you need to load the texture that lives here, content/stone. There's a PNG file that's stones. The stones texture is actually not green, by the way. Yeah, it's basically because that circle is green, and it makes this thing green on top of it. Okay. If you made that circle white, it would just draw the texture at the normal color. Okay. Okay. Then I asked you to do stuff with rectangles, more stuff with rectangles. Then we get to the random circles. This is just drawing circles of random shapes and colors. Then we get to the sprites. So I want to talk a little bit about sprites because by default, when you draw a sprite in SFML, it draws the entire size of the texture. Like literally, it will draw the entire thing full size on screen. Or it'll try to fit, it'll try to draw as much as it can, and whatever it can't draw goes off the edge of the window, right? But oftentimes when you're working with sprite sheets, one, it's actually a lot more efficient to work with a sprite sheet than it is to work with individual sprites, because working with a sprite sheet, you can load one time. Imagine you have to load every single one of these Pokemon. It takes a lot longer to load all these separate little images than it does to just load one big one. Computers are efficient at loading a single thing and doing that sequentially as opposed to figuring out all these little files. So the key here is that this thing has a unique size and it has a width and a height. But in SFML, you can specify a piece of what piece of this texture you want to actually draw. So you can specify, hey, I'm going to give you a rectangle of a certain size, and I'm going to put it at a certain position on this texture, and that's what I want you to draw. So in here, as part of the examples in the sprites and textures, right here, this section on you can draw your sprite. Okay, can I have my sprite now? This is what you're going to be using to draw that that Pokemon, the Pokemon image. You're going to create what's called a sprite. A sprite and a texture are two different things. A texture is the actual file that's loaded onto disk. A sprite is a way to draw a texture. A sprite is really just a rectangle that's had a texture applied to it. That's all it is. You can also do this with circles. You can do this with squares. You can do this with, you can technically draw a texture on a triangle. A sprite is just an efficient way to draw a texture on screen. And what's nice is that for sprites, you can also call this function right here, set texture rectangle. So what this does right here, what I have highlighted right here, this is how you specify where to start drawing your rectangle and how big it is. This right here represents where on X do you want to start your rectangle. Then this one here is where on Y do you want to start your rectangle. And this is the width and this is the height. So what you're actually doing here is you're calling a function called setTextureRect on your sprite. Sprite has a function on it you can call. And to it you're passing one argument. And that argument you're passing is a structure called intRectangle. This is actually just a structure here. And that structure needs 4 pieces of information to work correctly. And that thing is just where do you want to start and how big do you want it to be. Okay. So I want you to refer to this page when you're doing that Pokemon example and spend some time trying to figure out like how to get this thing to work for your sprite. So this right here is how you this section right here is how you're drawing your Pokemon. All right. And that's how you get Charizard out. That's how you get Wailing out and Wailord. And then this is how you get Link. And this is also how you draw this texture. It's actually loading 2 different textures, one for Link and one for the background, and then drawing the background and drawing Link on top of it. And once you get to figure out how you draw those specific sections, when you want to draw an explosion like this, animation is actually just tricking your eyes into thinking that something is moving, when really all you're doing is drawing a different piece of a texture all the time. So what is this program? Fireworks? I don't think I've ever used Fireworks, so I'm going to try my best to do this. So what you typically do is you specify a rectangle of what you want to draw. I'm actually going to do this. Hopefully it's similar enough to Photoshop where I can make this thing work. How do I get it to not fill? Does anyone? No fill. Okay. And then we will do. Okay. And we'll do 4. So I'm going to use this rectangle here to represent our UV, our rectangle that we're using to position. Whoa. Sure. Okay, there we go. So all animation is just basically taking this rectangle, drawing this, and then moving it here, drawing that, moving it here, drawing that, moving it here. You're moving this rectangle fast. Once you get to the end, you start over here, you draw that rectangle, move the rectangle that you're drawing. This rectangle here is the same rectangle that you're using to pull out, like, Link. You're drawing that Link rectangle. Which one do you want, right? Like, which one of these? This one is the one you want. But to get it to do his run cycle, it's just basically going through here to do his animation. Or Epona here can basically do this to go through his run animation. Okay? And so I'm going to go into more detail about animation stuff near the end of class to show you guys how animation works. But I want you guys to understand that this is kind of the general idea behind the animation. And I'm going to give this lab, let me copy this lab to Zool so you guys can all grab it. And then I'll give you guys the rest of class to work on it. All right, so have at it. And you guys can take a